Today, Earth is a planet teeming with life, but billions of years ago, conditions were far too harsh for organisms to survive outside of the oceans. One of the key developments that made Earth more hospitable was the formation of the ozone layer, a protective shield in our atmosphere that blocks harmful ultraviolet, or UV, radiation from the sun. Without the ozone layer, life as we know it would not be possible. In today's video, we'll explore how this vital layer formed, what it does to protect life, and why it remains so important for Earth's ecosystem today. Let's start by going back around 3.5 billion years, when the first forms of life emerged in Earth's oceans. At this time, Earth's atmosphere was vastly different from what it is now. It was rich in volcanic gases like methane, ammonia, and carbon dioxide, but contained little to no oxygen. In this oxygen-free environment, life was simple, consisting mostly of single-celled organisms like bacteria. Then, around 2.4 billion years ago, a major event changed everything. The appearance of photosynthetic organisms like cyanobacteria. Cyanobacteria could harness sunlight to produce energy, releasing oxygen as a byproduct through the process of photosynthesis. Over millions of years, these tiny organisms pumped oxygen into the oceans and, eventually, into the atmosphere, triggering what we now call the Great Oxygenation Event. This was a turning point in Earth's history, as it gradually transformed the atmosphere from an oxygen-poor environment to one where oxygen became a significant component. But the presence of oxygen alone wasn't enough to make Earth hospitable for life on land. While oxygen was a key building block, Earth was still bombarded by intense UV radiation from the sun. UV radiation can cause serious damage to living cells, leading to mutations and even death. For early life, especially life on land, UV radiation posed a major barrier to survival. This is where the ozone layer comes in. As oxygen levels in the atmosphere increased, some of this oxygen began to undergo chemical reactions driven by UV light from the sun. When UV light hits an oxygen molecule, which consists of two oxygen atoms, it can split the molecule apart, creating single oxygen atoms. These single oxygen atoms can then bond with other oxygen molecules, forming a new molecule made up of three oxygen atoms, known as ozone. Over time, these ozone molecules accumulated in a region of the atmosphere known as the stratosphere, forming what we now call the ozone layer. This layer wasn't very thick, but it was incredibly effective at absorbing most of the sun's harmful UV radiation. The ozone molecules absorb high-energy UV rays, breaking apart in the process, but then reforming again as long as there's enough oxygen present. This cycle of ozone formation and destruction became Earth's natural shield, allowing much less UV radiation to reach the surface. With the ozone layer in place, Earth became a much safer environment for life, especially for organisms venturing out of the oceans and onto land. By filtering out harmful UV rays, the ozone layer allowed for the evolution of complex life forms that could live, grow, and reproduce on land without being destroyed by radiation. This protective barrier paved the way for plants, animals, and eventually humans to exist on land. The ozone layer's importance to life on Earth can't be overstated. Today, it continues to protect all living organisms from the damaging effects of UV radiation. Excessive UV exposure can cause skin cancer, eye damage, and weaken immune systems in animals, including humans. For plants, UV radiation can interfere with growth, reducing crop yields and affecting ecosystems. Even marine life, particularly plankton, which forms the base of the ocean food chain, is vulnerable to UV radiation. But despite its stability for millions of years, the ozone layer is not invulnerable. In the 20th century, scientists discovered that human-made chemicals called chlorofluorocarbons, or CFCs, were damaging the ozone layer. CFCs were widely used in refrigeration, air conditioning, and aerosol sprays. When these chemicals reached the stratosphere, they broke down under UV light, releasing chlorine atoms that reacted with ozone molecules and destroyed them. This led to the formation of what we now know as the ozone hole, a thinning of the ozone layer, particularly over the Antarctic region. The discovery of the ozone hole was a wake-up call, showing that human activities could have a direct and potentially devastating impact on Earth's protective shield. In response, countries around the world came together to sign the Montreal Protocol in 1987, an international agreement to phase out the production of CFCs and other ozone-depleting substances. This agreement has been incredibly successful, and since then, the ozone layer has shown signs of recovery. The story of the ozone layer is a reminder of how interconnected life on Earth is with the planet's natural systems. A single layer of molecules in the atmosphere has made it possible for life to thrive on land, protecting plants, animals, and humans from UV radiation. And while it's something we can't see with our eyes, the ozone layer remains one of Earth's most crucial features. Thank you for watching. If you enjoyed learning about the formation of the ozone layer and its role in protecting life, don't forget to subscribe for more deep dives into the history of Earth and the evolution of life. And check out our quiz shorts to test your knowledge on Earth's unique and life-sustaining features. See you in the next video.